We're diving into the dreaded org.apache.Spark.SparkException, Job Aborted Error in your Python Spark applications. This error is a common headache, often masking the real problem. Let's break down how to troubleshoot and fix it. 1. Understanding the error. The job aborted message itself is vague. It's Spark's way of saying something went wrong during a Spark job execution, preventing completion. The key is to look beyond the headline error. Spark typically provides a more detailed stack trace, often buried within the error message. This stack trace is crucial for diagnosis. It pinpoints the specific line of code or operation that failed. 2. Resource exhaustion. A frequent cause is running out of resources on your Spark cluster, like memory or CPU. Your Spark application might be attempting to process more data than your cluster can handle. Check your Spark cluster's resource monitor to see CPU and memory utilization during job execution. If they're pegged at 100%, you need more resources, more nodes, larger node instances, or more efficient code. 3. Data issues. Problems with your input data are another major culprit. Corrupt, incomplete, or malformed data can trigger this error. Carefully examine your data source for errors. Look for inconsistencies in data format, missing values, or unexpected data types. Consider using Spark's built-in data validation functions to check the integrity of your data before processing. 4. Code bugs. Errors in your Python code are a very common reason for job abortion. Simple coding mistakes, like incorrect data manipulation or logic flaws, can cause Spark to crash. Carefully review your code, paying close attention to loops, transformations, and actions. Use debugging techniques, print statements or a debugger, to trace the flow of your program and identify potential errors. 5. Network problems. Network connectivity issues between your driver and executors can lead to job failures. Check your network configuration and ensure that your Spark nodes can communicate effectively. Transient network glitches can also cause these errors. Retry mechanisms within your Spark code might be helpful to mitigate this type of issue. 6. Driver failures. The Spark driver is the master process coordinating your jobs. If the driver crashes, the entire job is aborted. Common causes are out-of-memory errors on the driver node or issues in the driver's code. Ensure your driver has sufficient resources and carefully debug driver-related code. 7. Executor failures. Executors are worker processes that perform the actual computations. Failures here can also abort the job. Check the logs of your executors for errors. These often contain more specific hints. 8. Debugging strategies. Spark provides extensive logging. Configure more verbose logging levels to capture detailed information about job execution. Use Spark's web UI to monitor job progress and resource utilization. The UI shows execution graphs, task completion rates, and detailed stage information which can help isolate bottlenecks. By systematically investigating these potential causes and utilizing Spark's debugging tools, you can effectively track down and resolve job aborted errors, making your Spark applications more robust. Remember to check your Spark logs and the web UI for more detailed error messages. These messages are essential to finding the actual root cause.